please join me in giving a warm welcome to our next speakers.
Hello, everyone. It's really exciting to be here at the Delhaize Summit. So today we are going to talk about serverless model endpoint deployment and a little bit about ourselves. So I'm a lead machine learning engineer at Ahold Delhaize, doing machine learning operations transformation across the brands. Ahold Delhaize is one of the largest food retailers in the world with 19 different brands, some in the US, some in Europe. I have 7 years experience in MLOps, and when MLOps wasn't even a thing, we already built some platforms that allowed for automated machine learning model deployments. And in total, I have 10 years experience in data analytics field. I started as a data analyst, moved into data science field, and then when there was no one who could put models in production, I became a machine learning engineer, a stayed one. So happy to see you all.
And hi everyone, my name is Başak. I'm also a machine learning engineer at Ahold Delhaize. I'm mainly responsible for deploying and maintaining machine learning models, data science projects, and I'm also developing tools for machine learning operations in my current role, and I've been working in this field already for 5 years. So during our talk, we will give some links to repositories and articles under the account name Marvelous MLOps. So what is Marvelous MLOps? 5-second introduction. Maria and I are big fan of Marvel and MLOps, and we wanted to start our blog, and we asked ChatGPT to give us a name, and it generated for us Marvelous MLOps, so that's how we had our start. We even have matching link with Infinity Stones, but this only makes sense to you if you're a Marvel fan. Are there any Marvel fans? That's pretty good, yeah, nice. We have a full agenda, so let's start. We will start with a quick introduction to Ahold Delhaize and our role there, and we'll talk about our current solution for API deployments. Then we will show you 2 use cases from our data science teams, and we'll deep dive into some implementations. And then we will show you how to automate things using workflows, and then we will wrap up with conclusion. So our objective today is to prove 2 things. First, Databricks Serverless Model Endpoint can be a great tool for your real-time inference models. And 2, this SpongeBob meme with rainbow can fit in every context. You'll see. Maria already mentioned our company. Ahold Delhaize is one of the biggest, larger food retailers in the world. It's multinational. We have 19 brands. If you're coming from the East Coast of the United States, we also have 5 brands there, like Food Lion, Hannaford, Giant, Fresh Direct. They might be familiar to you. We are working in a department, digital department, which is more of a central unit that supports brands, local brands within Europe. And our domain is data science. So we provide data science and MLOps support to our brands within Europe. Currently, we're supporting 6. We are supporting more than 25 projects in total. It's a lot of work, but it is fun. And this is our current solution for API deployment. We love simplicity. Simplifying processes is our secret weapon to support all these more than 25 projects. And this diagram has only must-have components. So we have, of course, data lake. We have GitHub as version control. We use Databricks to train our models and for batch prediction. We use MLflow as model registry and Azure Container Registry as our Docker registry. And of course, we serve our APIs in Kubernetes. So this end-to-end solution has only must-have components. It's already simple, but we can even make it simpler. So that's why we wanted to adopt serverless approach, because who needs drama when you can have serverless happily ever after? Speaking of dramas, actually we had some challenges that motivated us to move towards serverless. First of all, we don't have a team managing Kubernetes. Optimizing Kubernetes, effectively maintaining them can be actually quite time consuming, and we are only ML engineers. We don't have time to play the role of platform engineers. Our brands, some of our brands have Kubernetes with different setups. So some has pull deployment, some has push deployment. So it makes it difficult to standardize processes, and we want to achieve uniform and consistent way of working among brands because it's easier to support all of them. And also it makes it easier to scale our models among brands. So Another reason that we want to use serverless is because some brands do not have Kubernetes, which cannot have API-based solutions. So what does serverless brings to us? So we are supporting in total 6 brands, and all brands have Databricks. So one component that is common among all brands is Databricks. So we're trying to use Databricks for more functionality. Serverless will certainly reduce complexity because we don't have to maintain the infrastructure anymore. It will make it easy to also deploy API-based solutions for our brands, which do not have Kubernetes infrastructure already. So it may make it easy to roll out our API-based models. And we also expect to have some possible cost savings because we're not really using Kubernetes optimal and effective. Okay, now time for use cases.
So we have two different use cases with Ahold Delhaize. One is classifier model. It's a very simple classification model based on text that associate in the store, put in the app. And it's a scikit-learn model, so there is nothing special about it. If you know MLflow supports scikit-learn natively, so it actually makes it very easy and simple to use. But other solutions that we have are not that simple. It's a cross-sell model which is served on the basket page of our website. So when you come to the basket, you have some items in the basket, you will get recommendation from the model what other items you may want to buy. So, and this is a custom model. That's a model that we built together with University of Amsterdam, and it's really stacked, complex thing. We cannot talk much about that, unfortunately, but that's a complex model, and we need to put a wrapper around it because we cannot use just simple scikit-learn class for this. So when it comes to Questifier, it's deployed to a brand called Ethos in the Netherlands, and associates in the store may have some questions, and they use an app that is developed for the associates in the store, and they send it further to Salesforce. So that's how it may look like. And that associate says we don't have stock of certain item, then it puts it in the app, and app sends it to Salesforce, and Salesforce will then call the API, Questifier API, and it will return the classification of this question. So in this case, it will be replenishment, and then this will be sent over to the correct team that can handle that issue. So if the model was not there, then it would be a person that manually would classify those questions into the tasks. And it takes time and not efficient. So having an API in place actually makes it really easy for us. And another use case is a cross-sell. So it's deployed, actually it's deployed to 4 brands, to 3 brands. It's really deployed already using serverless API deployment, and another brand we are working on that currently. And there are three data dimensions here that we use: transaction data, article data, and customer data. And it's a complex model, as I mentioned. So personalized model, item association model, and frequency model stacked together in Ensemble. So how does it look like? It's one of the online stores that we have, and if you add spaghetti to the basket, you will get suggestions of some tomato sauce. Well, that makes sense. So because we cannot really deep dive in our actual models and our actual data, and we wanted to talk about the actual deployment, how that would work for you, and make it really easy to apply if you're interested to do so, we mapped it into Amazon use case. So Amazon data, Amazon reviews data, it's a public data set that is available for everyone, and it's close enough to our data. It's also a retailer. So we mapped the Questifier model into a model for classification of the reviews. The reviews can be of different categories, and based on the review text, we classify the category of the product. And the cross-sell, we actually map also to cross-sell use case. We recommend the product based on the reviews. So you have that product, what other products you may want to to add to your basket based on it. And we use review data for this and the rating of the reviews for this. We will not really go into the models itself. We're not data scientists, we're machine learning engineers, and don't take the model that we have there seriously. We are really concentrated on the deployment type of things here.
Okay. Yeah. So this is the moment where we will deep dive into the code implementation. So I'm warning you, you're going to see a lot of code snippets, but they're going to be short and clear. What we will show now is we will show how to create model endpoint for built-in model, sklearn, and for a custom model that you write yourself. And we will share some problems we faced and the solutions we generated for those, and we'll also give you some warnings and limitations. As Maria mentioned, we're using Amazon public dataset. If you Google Amazon reviews from 95 to 2013, you'll see it. It has categories like gourmet food, pet supply, health, and baby. So we're using this public dataset for our mimicked use cases. And this is our source code. Usually source codes are given at the end, but we don't follow the standard flow. In case you want to deep dive into the code already and see the entire implementation, this is the repository that we take all the code snippets from, that you will see also some example implementations and also example workflows. Okay, so our very first use case was question classifier that we mimicked as classifying reviews, so that the input and output structure is going to be the same. So we give text input and then we get predicted label as an output. And we will follow these steps. If you're from data science domain, these are very intuitive for you. We will start with loading the data, we will train our model, and we will create model endpoint based on our trained model, and then we will query our endpoint once we create the endpoint. So it's very simple. And loading data is, all our code is based in Python, except the workflows, which are in GitHub Actions, but all our implementations are Python, the most common language among data scientists. And we implemented a Python class, Amazon data loader, which loads the data in a data frame. And this is the data frame, how it looks like. We have columns like product ID, title, score, the text, which is the review, and the category, which is the label. The second part is training the model. As Maria mentioned, we're not data scientists, we're ML engineers, so do not focus on the model itself, but we want to focus on the ML flow part of it. So we're creating a scikit-learn pipeline with count vectorizer, TF-IDF, and logistic regression as a classifier. And we train with MLflow in an MLflow run, because Databricks model endpoint is actually highly integrated with MLflow. You have to use MLflow to log and register your model to be able to create model endpoint. And because this is a built-in model, so MLflow already has sklearn package within it, all we need to do is just MLflow sklearn autolog, and it logs the model already. And once we run the training part, Okay. Once we fit our model, we need to register our model by running MLflow register model. So this is the last step you need to make sure that you do, because this is how you can actually create model endpoint based on your registered models. Once you execute this code, you will see that your model successfully registered. If this is the first time that you're registering model with the given name, you'll see version 1. But the more you run this code, you will see that the version number is increasing. And if you go to Databricks UI, on the left, you select machine learning and models section. Under the registered models, you'll see that your model is there. So in our case, our model name is Amazon category model. So the third step is creating model endpoint. So we train our model, we register our model, now we can create model endpoint. There are two ways to do it. You can either use the UI, so you go to your registered model version page, and then you can just say, create model endpoint. But in the world of MLOps, we like everything code-based, we like automation if possible, so we wrote a Python wrapper to actually call Databricks REST API. It's very simple, it's exactly like this, it's short. Our function called serve ML model endpoint is just calling the Databricks REST API for creating model endpoint, and it passes all the information required. In this case, we create a config file, well, config data structure, which needs certain attributes like model name, model version. Workflow size is t-shirt size, like small, medium, large. It stands for the requests per second. But I think this will go away soon with the new versions, and if not yet. And once you have the config file, you just pass this config file as data structure to the model endpoint, and it creates your model endpoint. Once you create your model endpoint, you can also query it, obviously. It's also easy. You just use REST API again, because you already have your model endpoint URL, and you pass your data as a JSON file to the model endpoint. In this case, our input for the model is text. So we are passing 2 inputs within an array. I can't see it, but. So the first input is, oh man, the best cereals I've ever had, a lot of nuts, I love nuts. And the first prediction our model gives is gourmet food. The second is a lot of base face serum contains vitamin C, panthenol, and your skin glows, and our model predicts as beauty. So it gives some meaningful results, although it's a very simple model. So this is how you can query your model endpoint. So the second use case we had is cross-sell, product recommender. And our mimicked version is also recommending product for the sake of same input, same output structure. We're going to follow the exact steps. We're going to load data, we're going to train our model, we're going to register our model, and then create the model endpoint, and then we will query our model endpoint. And the loading part is exactly the same, because we are using the same loader class, and we're using the same Amazon dataset. The training part is where all the fun starts. So in order to register your model, your custom model with MLflow, you need to use PyFunc, MLflow PyFunc functionality. So your model class needs to inherit PyFunc. And if you want to log your model within MLflow, you need to run MLflow PyFunc log model. In our previous case, it was a built-in model, so we run MLflow sklearn log model. In this case, we're using PyFunc. And once you log your model, you can also register your model using the same function, so MLflow register model. So this step is important, again, to create a model endpoint. We will deep dive into some specifications in this code piece in the later slides, but for now, the key point here is our model class has PyFunc inheritance, and we're logging our model using PyFunc within MLflow. And the creating model endpoint is also the same. We prepare our config file. If you remember from the previous slide, we had a serve ML model endpoint function, which is just a Python wrapper for calling Databricks REST API. And we pass our config with model name, model version, the workflow size, and I think these are like more or less all the attributes you need to provide. There are a few more, but it's not more than that in this config file. And once you create your model endpoint, it's time to query. In this use case, our model input is a dictionary of 2 attributes: customer ID as a string, and a basket as a list of basket items in the customer basket while shopping. And as we did before, we're sending our input data as a JSON format to the model endpoint. And in this case, we have a baby product in our basket, and the suggested products are also baby products. So it is also giving some meaningful results. Okay, so when we work with our custom models, we encountered some problems, and we generated some solutions that we will share with you in case you also want to deploy a custom model using serverless. The very first one is a PySpark dependency. If you are deploying a custom model, it's likely that you will have some custom libraries that are not default and available. So the way how you are suggested to do on the documentations, the documentation is the link below, is that you need to use the function called MLflow utils add libraries to model. What this function does is it takes the dependencies that you define within MLflow content environment as pip dependencies. It takes these dependencies, it creates wheel file for them. But if you add PySpark as your dependency, it does not create the wheel file, and it gives the error at the stage where you want to create your model endpoint. It doesn't give error at the stage where you register your model, but it gives error at the stage where you want to create model endpoint. So to solve this issue, we just wanted to avoid using this function add libraries to model, and instead what we did is we created a wheel file of our custom dependency and added to somewhere in the DBFS, and we provided the path to this wheel file as a dependency within our Conda environment variables, Conda environment dependencies. And in this way, you're just given a dependency as a code and the path to the code, which is actually the wheel file somewhere in the DBFS. And this works because we don't need to run the function that adds libraries to model to create a wheel file because we are already given a wheel file. So this worked for us in case you also have at some point a PySpark dependency. The second sort of a problem or warning that we encountered is the input structure. So inputs provided to the model endpoint are by default transformed into NumPy projects. You don't realize it in case you get an error saying that, oh, the data is expected to be list, but it is NumPy object. And in order to make sure that your model predict function gets the model input as required, we just enforce the expected data structure within our predict function. So our model predict function is the one below, and once we get the input from endpoint, we just make sure that in our case, customer ID is string by just converting that back to string, and the basket, which is list of strings, is also converted back to the string list of strings. And this way, we make sure our prediction function gets the input as it expects the proper data structure. So this is how we solved this model input problem. We have an attention point here. So you can create a model endpoint by running create model endpoint. And if you don't have any model running on that endpoint, you can see that your model endpoint is created and the version is the one that you just passed. However, if you are already running a model in the model endpoint, which is in the production stage, and if you want to update it with a version that is not in the production stage, then you won't get it updated. So remember to transition your model version to the production stage before creating a model endpoint in order to make sure that you update your model endpoint with the intended version. So this is one of the attention points that you need to pay attention. Okay, time for automation.
I think that's the most interesting part, how you automate this. So what we have given so far is an example of a notebook that you could just run and see how it works. But in reality, you want to use it in production, so it has to be automated. So to automate that, we need multiple steps. I will go through a Databricks job example, model training script, model deployment script, GitHub Actions workflow, and important things that you need to know to get it working. So if we look how the job structure looks like, there are in essence two steps. There is a step to train the model and there is a step to deploy a model. And those two steps, they both run a Python file and they share a cluster. In this case, it's the same cluster called recommend the cluster because you don't want to wait for another job cluster to be created to run yet another step. So to do the automation, we use DPX deployment. I don't know whether you're familiar with DPX. I think it's a great tool by Databricks Labs that actually simplifies the whole process of deployment of jobs on Databricks. And we pass certain things to our job using this DBX file. We pass run ID and we pass job ID. Those are task parameter variables in Databricks that make your life easier. I will show later how we actually use those variables and why exactly they are handy. But it's possible anyways to pass these parameters, and they will be filled in at the moment that the job starts running. So that's very useful. So also what we pass as well are things like Databricks host, Databricks token, and Git tag, Git SHA. So those things come from environment, will be available as environment variables, so that you can also use them in your script. And Databricks token is stored in secret, it's in Key Vault. And there is a scope, Databricks scope, that is Key Vault backed, that is created, so that we can access it without it being shown anywhere in the logs. So that's a safe and robust way of doing so. And if we see how we actually use it, we make things traceable. So this Git SHA, run ID, and job ID can be caught in the Python script, in the training script, so that we can access this information. And we create tags. We register model with the tags where we provide this run ID and job ID. This is something that Databricks doesn't do by default. If you don't do that, it would be very hard to find a model that corresponds to a certain run. So by providing these tags, we make models searchable. So if you can see also on the right side of this slide, if you go to the UI, you will see models which are registered, and you will see that they have those tags. So that's exactly the part that makes it searchable. And the way how we use it is in model deployment script. The thing is, when we train the model, it was registered under a certain version. So the next step is model deployment script, and how we can actually get that model version that was just registered. So there are multiple ways to do so. It's possible to do it via dbutils. dbutils has an option to actually catch some input from one step and pass it on to another step. But we find it not very convenient to use, because dbutils doesn't make things testable locally. So we have the way of doing unit testing, and it really doesn't make it easy if dbutils is there. You would have to build up some wrappers if you want to run it on a local environment. dbutils is only accessible on Databricks environment. So if we're doing it this way, at least, we don't have this problem with dbutils. So because both steps in the job, they share the same parent run ID, and we tagged the model with the run ID, we can actually search for it in the next step by the run ID, which is also available here. So, and then we get the version of the model, we get the model URI, and then we can actually deploy it. So that's a simple trick that we do, which we find very useful, and we like to keep things clean, so it's a nice way of doing so. If you consider doing this, I really recommend it. So then we go to GitHub Actions workflow. In GitHub Actions workflow, we set certain environment variables like Git SHA, Databricks host, and Databricks token. The token that comes from the secret of the repository, and it's a service principles token. You could choose also to instead use Azure credentials as a secret if you're on Azure, and you could create a token on Go in your GitHub Actions. But just for simplicity purpose, I think Databricks token is nice, because you could also test it easier. So that's the first step. We define the environment variable inside your GitHub Actions pipeline. Then you configure DBX project, because we use DBX. Then run DBX deploy and DBX launch. So DBX deploy part will then create a job. It will be also visible then in UI. But you also, if you want to start a job, start and run of the job, it's also possible to do so via DBX launch. But you don't always want to do that. Actually, you want to have CI/CD and orchestration totally separated from each other. And in DBX, you could also add a schedule for your job. So you could say you want to do this retraining and deployment, let's say every 2 weeks or every month. So then you don't launch it at the moment that you update your code. You just update the definition of the job. It will know what code it came from, because we tag everything with Git SHA, so we can always go back to the code. and it actually keeps it clean and separated this way. So there are some important steps to get things working. So I mentioned you need to have a service principal. A service principal is better than using personal access tokens. I hope no one here does it. So to get a token for service principal, it's not easy in Azure. So you have to get AAD token first, and with that token you have to call a token API to get the token with a long lifetime. Because if you do it first time, it's only valid for 60 minutes. But you want the token to be available for a long time because you want to store it also in the secrets. So that's an important step to pay attention to. And you need to have key vault-backed secret scope in Databricks where you store it. So those things are important. And the conclusion. So it's made it really easier for us to use serverless model endpoint comparing to Kubernetes deployments, because we don't really have an orchestration system, the central orchestration system, and we do like to use Databricks workflows. And if we had to deploy in Kubernetes, it's unfortunately not possible to do it from Databricks workflows. So we kind of misuse GitHub Actions to do the deployments for us and schedule things there, which can lead to some problems. So if we could keep it in one place and orchestrate in one place, it actually makes our life much easier. So this adds this simplicity to it. It is scalable to the brands with no Kubernetes. So we have, at the platform team we work with, there are 4 brands with some Kubernetes, and there is one guy handling this Kubernetes. So if that guy is gone, we are in trouble. So basically, to make it simpler for ourselves, we eliminate this kind of risks and go for it. And there are also brands that are considering to have some real-time inference models, but they don't have anyone at all to help them out. So then they actually can reuse what we provide as a framework, and they can go on with that implementation. It is possible to create this model endpoint deployment for complex solutions, like we have shown with the PyFunk wrapper around it. And it is very easy to automate with DBX. So thank you very much for your attention.